Yes, hi guys. Today I'm taking the continuation of questions based on cuboid and cube or cube and cuboid. Okay. So initially the previous lecture series, I took some of the questions and these are some level of difficult one because some of the students have asked me these questions also. So I've taken these questions in this second lecture series of the same topic, cube and cuboid, questions based on cube and cuboid. Okay, and now these questions will further clarify what is the basics of cuboid and cube. Okay, how the questions are based on them and they are being calculated. Okay, so let me take these questions one by one. First question, taking this directly because the basics I have already clarified that what are the questions. Four formulae are applied for cuboid and four formulae for cube. Both are of the same type, but cuboid is a basics having rectangle, parallelepiped, etc. Okay, but in case of a cube, the base of the floor and roof, all the sides are equal squares. Okay, or they have the congruent squares, you may say. That is a cube. The shape of a cube is just having height and length and breadth equal. They are equal to one unit or one quantity. I mean, just like a side, take suppose the side is A, or any side we can take, or symbolically we can denote it by any number or any digit. Let me take, so any digit we can take. Here A, we have taken the alphabetical letter, and that in that situation we just assume that side of that equivalent. So in case of cube, all the sides are equal, but in case of length, breadth and height, I mean in case of a cuboid, length, breadth and height are different. Two may be similar, but not all are three equal, because otherwise it will take a shape of a cube. Okay, so at least two sides may be equal. Okay, but all the three sides are not equal in case of a cuboid. Shape of cuboid and cube, they are obviously different from each other. Okay, so let me take these questions based on them one by one. First question is, it says that rectangular tiles, let me take question number one. I mean, this says rectangular tiles, okay, tiles are rectangular shape, each of the size 60 centimeter by 40 centimeter, must be laid, okay, horizontally on a rectangular floor of size 120 centimeter by 170 centimeter. Okay, so this is the side of the floor area such that the tiles do not overlap. Undoubtedly, the tiles will not overlap. They are to be put one after the other. Means their edges are being joined to each other. Okay, so in that situation, we have to find out number of tiles do not overlap, and a tile can be placed in any orientation so long as its edges are parallel to the edges of the floor. Okay, its edges are parallel to the edges of the floor, means they are not overlapping each other. They are being suited in such a manner that they are not okay, they can be placed in any orientation. Okay, left to right, or doesn't matter orientation, so long as its edges are parallel to the edges of the floor. No tile should overshoot any edge of the floor. I mean, not coming over the other edge of the another tile. So all the tiles are having the parallel edges to the edges of the floor. Okay, they are just level in the level field. They are being placed. They are not overlapping each other. They are not coming one upon the other. Even the edges are not touching them. I mean, on over this, they are touching each other, but not overlapping each other. That is the point. So that can be accommodated on the floor. Is what? What is the number of number of tiles? Oh, sorry, no tile should overshoot any edge of the floor. So the maximum number of tiles that can be accommodated on the floor is what? What is the number of tiles which can be accommodated on this floor? Let me take, as I tell you, that whenever the number of anything is calculated, the smaller one is calculated, then we put, if it is area, then we put the area of the larger side in the numerator and the smaller side in the denominator. The number of which is being calculated, that area or volume is put in the denominator. Okay, in this case the tile is a smaller one. Tiles are being placed in floor, okay, or in the floor. the plane of the floor. So in this way, the number of tiles is to be calculated. So the area, in this case, area is there because area of the floor is being calculated. So area of the floor in the numerator divided by area of the one tile. That will give us the number of tiles. In this way, we have to calculate what is the number of maximum number. If it is in points, suppose in decimal the value is coming, then before decimal, whatever the minimum number is there, that is the maximum number of tiles can be calculated. Okay, sorry friends, so much tired because I was just overworking. Now come to the point. So number of tiles we have to find out. So let me take what is given to us. Here we are given. Why I just first take this, pronounce the whole question so that one can understand that what is the question all about. After that I write given and what to do, then the question is clear. These questions, if are not zoomable, they can be zoomable if somebody is just downloading them, and after downloading they can be just zoomed, okay, and they can be seen that what question is being written there. And even if not zoomed, I can just pronounce each and every word of this. After that I will solve the question. This is my process so that I can just understand that what the question given here, okay, because otherwise taking notes in hand is very difficult task, it's taking time. So let me take this one. Now in this case, rectangular tiles, each of the size 60 centimeter by 40 centimeter. Okay, so let me take what is given to us. We are given here the size or rectangular tiles for each. The size of tiles, that's the size of tiles are or is being are as follows. For the length and breadth, so 60 centimeter by, this is dimension 60 centimeter by 40 centimeter. Area, length 60 centimeter, breadth is 40 centimeter. This is size of one tile. We laid horizontally on a rectangular floor, and of the floor size is as follows, or size are as follows. Size here means length and breadth, okay, are as follows. Are as follows. What are the sizes? Are as follows. Here size are length and breadth. What is the length and breadth of this? So this is 120 centimeter by 170 centimeter. Okay, 110 centimeter by 170 centimeter. All right. Now in this case, no tile should overlap. Okay, so number of tiles we have to find out. So what we have to find out? To find here number of tiles used to cover the floor. That is the point here. Solution. Now see the solution here. The solution. The number of tiles. Let me write here. As I have told you, number of, this is a formula. Number of tiles is equal to area of the floor divided by area of a tile. Area of a tile. This is 120. Area of the floor is 120 centimeter by 170 divided by, this is 60 by 40 into 60 by 40. What is 60 2 ja 120, 0 cancel out, 17 2 ja 32, 34 by 4 is 17 by 2, 2 ja and 2 17 times 17 by 2, this is equal to 8.5. So maximum number of tiles is 8, because 8 is the actual number. We have to find out number in integers, the form of integers, nothing given but maximum number of tiles that can be accommodated on the floor. So maximum number of tiles is this 8.5. 0.5 is just neglected. Okay, therefore maximum number of tiles, therefore maximum number of tiles is equal to 8. This is the answer. This is the answer here. Number of tiles used here is 8. Okay, this is question number 1. Now let us talk about question number 2. What is question number 2? Say, let me check what is given there. Okay, so first pronounce it. What is given, each and every word of this let me pronounce, and after that you'll understand that what is question being given, what is all about intent of the question. Question second is, it says 4 identical small squares of side k centimeter, okay, are cut from each corner of a bigger square, okay, of a bigger square, the side of which is 20 centimeter. Okay, so bigger square from which a square side from all the 4 corners of size k, of side centimeter k centimeter, is being cut from a bigger square of side 20 centimeter. So the side of the bigger square is 20 centimeter. Out of this 4 corners are being cut with side k centimeter. Okay. Now the remaining portion is folded. The remaining portion is folded. Okay, to form a cuboidal box with an open top, the volume of which is v centimeter cube. Alright. If k is an integer, what should be the value of k to maximize v? Volume must be maximum. Let me just find out what is the value of v in that situation, or sorry, value of k. What can be the value of k so that the value of v, the volume, is maximum? Okay, let me take what is given to us. Question number 2. Very interesting question. Here we are given a bigger square of size 20 centimeter side and a square of side k centimeter is cut from 4 corners of the bigger square to find here, to find the maximum value of k, maximum value of k, so that the open box formed by folding the remaining paper, into an open box. Okay, so that the open box formed by folding the remaining paper. Okay, no need of writing again into open box. Okay, in that open box we have to find out what is the value of k. Now let me just check that this is, suppose a square here. This is a square. Okay, out of this is 4 corners. These 4 corners of side k centimeter is being cut. K centimeter, okay, is being cut when the box is being opened, so what is the side here? Total size is 20. Out of that 20 minus 2k is the size of remaining 20 minus 2k. This is also 20 minus 2k. 20 minus 2k. Why 2k? Because k this side and k this side. So out of this 20, 2k, k plus k, 2k is being subtracted. So this remaining size is 20 minus 2k. 20 minus 2k is the side of the remaining paper, remaining square. Okay, and that is being folded of height k centimeter. With height k centimeter, that side is being folded. Okay, so that we have to find out what is the value of k to make his volume maximum. Now volume of this solution, let me find out. Real volume will be the volume. This is length, breadth and height, because that open box will have the volume length, breadth into height. So length here, length will be, so V is equal to L into B into H, length, breadth into height. But length, breadth and height, length is 20 minus 2k. This is also 20 minus 2k. Breadth is also 20 minus 2k. Height is k into k. Or this is equal to k into 20 minus 2k whole square. Or we can take it is 10 minus k whole square. Okay. Or now we have to find out what is the value of k, maximum value of k. Now I have to substitute some value of k. K, suppose let's 1, 2, 3, 4, etc. Now we have to see that initial value will be minimum, then middle value may be maximum. After that the value decreases of this volume here. So let me take what is that maximum value for this purpose. Let me take this here. Okay, let me find the solution here. So putting k is equal to 1, 2, 3, 4, etc. So we get to v is equal to, if I take k is equal to 1, this is 1 into 20 minus 2 into 1 means 2 in whole square. This is 1 into 18 square. Now 18 is 324. Why? Because 18 into 18. Let me take 18 into 18. This is 18 into 18. So 8 8 is 64. 4 6 carry. 8 1 8, 8 1 8, 16, 16 and 6. 16 and 6 22. 2 carry. 1 into 1 1, 1 and 2 3. So 324. This is coming 324. The volume is coming 324. In the case when k is 1. Now let me take k is equal to 2. And when k is equal to 2, then it is 2 into 20 minus 2 into k 4 whole square. That means 2 into 20 minus 4 is 16. 16 square. This is 2 into 16 square is 256. 256. 16 into 16. This we know about. But the multiplication 2 6 is 12, 2 1 carry. 2 5 is 10, 1 11. 2 2 is 4 and 1 5. 512. Okay. This is 512. Let me write here. 512. Maximum value, I mean, increasing, is it 324 initially volume was total volume. For k is equal to 1, k is equal to 2, 512. Let me take other values. Let me remove this now. Now figure is clear. So next value of v at k is equal to 3. So this is 3. 3 we have taken now. This 2 we have taken. Now at 3, 20 minus 3 to the 6 whole square. That means 3 into 20 minus 6 is 14 square. Is 14 square. 14 square is 3 into 196. 14 into 14. Let's multiply this 14 into 14. If we know about, we know that over the table of this, but let me clarify this. 4 4 is 16, 6, 1 carry. 4 1 is 4, 4 1 is 4, 8, and 8 and 1 9. And 1 into 1 1. So this is 196. Multiply this by 3. Multiplication will give us 3, 6 are 18, 8, 1 carry, 3 9 are 27, 1 28, 2 8, 2 carry, 3 1 are 3 and 2, 5, 588. So this is again increasing, 512. Let me put 4. At 4 it is 4 into k into, the formula was k into 20 minus 2k whole square. Alright, this is the value of v. In this formula we are applying this whole square. So k is 4, 4 into 20 minus 2 into k, 4 to the 8 whole square. This is 4 into 20 minus 8 is 12, 12 square. This is 4 into 144, 12 square is 144 we know. So 4 4 is 16, 6, 1 carry, 4 4 is 16, 1 17, 1 carry, 4 1 is 4 and 1, 5. This is 570, now it is decreasing. 588 is maximum for 3 and for 4 it is 576, decreasing. 588 is bigger than percent, so k is equal to 3 is the maximum value of k. Okay, so here we see that for k the value of volume is maximum, hence for k is equal to 3, the value of v volume, the value of v or volume of the open box is maximum. Of the open box is maximum. Okay, so this k is equal to 3 is the answer. So k must be 3 here. What the point? Here k is equal to 3. So k is equal to 3 is the answer. Hence question number 2 completed. This is the process of solving this question. Now let us take the next question. So please try to understand that how these questions are being solved. So this kind of questions are coming in competitive examinations like GMAT and CAT, MAT, WA, the assistant administrative officers, bank provisional officers, IS, BTS as well. In competitive examinations, geometry, in case of solid geometry, these questions are coming there. So please just note down how to solve these questions. Their basics formally must be known to us. Only then we can solve the questions. Now, third question. This was question number 2 because these are word problems. Mostly word problems are written in lengthy portion, but they are written in less number because only question 8 were noted down here. Okay. In this way, I can go for number of lectures, but I'll take only 2 lectures based on each topic of this. Okay. Or I'm taking 2 topics together, like cube and cuboid. After that, I'll take cylinder and cone. Then sphere and hemisphere. After that, frustum, prism. Okay, and prism and pyramid, and frustum of prism. Frustum of pyramid and frustum of cone. That I'll take.